Hi everybody, it's Nil. Today we'll be solving a DP task together. It's called Teleportation. You can find it under Test Exam 2023 Summer on CodeExpert. Let's start by reading the question together. As before, on the left-hand side I have the question and the right-hand side I will use for the notes that I would make in an exam. So, you are given an array A that starts from 0 goes to n minus 2 of n minus 1 integers, and you are also given a non-negative integer v. Okay, so I would make these notes. We have an array that starts from 0 goes till n minus 1, n minus 2, has n minus 1 integers. And we have a v that is bigger than or equal to 0. So these kind of notes are really important to keep in mind because these things will be like how we define our DP calculation, how we define our for loops. And it can be really frustrating. It can get really frustrating. You know this if you've tried some on your own. Because even if you have the right solution, these borders are really important because if you miss a thing or two, it can cause you 0 points. So that's really important to note. Okay, let's move on. This input describes a game in which you start at level 0 with V francs. The goal is to reach level n minus 1. Okay, so we have levels. We start at level 0 with V francs. Okay, and the goal is to reach level n minus 1. So, okay, we probably will use those V francs in some way or another, which will be described in the following, but till now we know that we have a thing called levels. We start at 0, we try to reach n minus 1, this is the goal, and we have V francs. Okay, we are probably gonna jump around this. So, to play the game, you can take steps of the following type. Okay, so we will probably construct our recursion from this. So let's read really carefully. For any I with starting from 0 going till n minus 2, you can move from level I to level I plus 1 for free, or you can teleport from level I to level A of I by paying 1 francs. That is, if you had V francs before the step, you have V minus 1 francs after the step. You can take such a step only if you have at least 1 francs before you take it. Okay. So, steps. So the thing that you have to ask yourselves here is, okay, let me also note for any I. So the thing that you have to ask yourselves is, what can happen at level I? So that is how you define your recursion. So we're at level I, what can happen? We can go to level I plus 1 for free, or we can go to level A of I by paying 1 francs. That is, let me also note the regulation here. So if you add V before your step, then that V becomes V minus 1. And you can take such a step only if v is at least 1 before you take it. Sounds plausible because you can't pay 0 francs. Like 0 francs means basically you have no francs. Okay, so we guarantee that for any I bits starting from 0 till n minus 2, the array satisfies I is smaller than a of I, then that is smaller than or equal to n minus 1, that is you cannot teleport backward. Okay, this is cool, it will be easier. And what is the minimum number? Okay, this thing is what we're looking for. So what is the minimum number of steps you need to reach level n minus 1? Note that it is always possible to reach level n minus 1 in n minus 1 steps. So this is important. Worst case scenario, we will have this as an answer. By only taking steps that are free. So this means like you can start from level 0 and go to level 1, level 2, and reach n minus 1 at all times with 0 francs, right? It's okay. And let's look at an example. For example, for n is equal to 9, we have this, and v is equal to 2. The number of steps is, the minimum number of steps is 4. How does that happen? Okay, it starts from level 0, goes to level 1 without no francs, goes to level 2 without no francs. Then it goes to level 5, it has to pay here. The v is now like 1. And then from that, it goes to level 8, which is like here. Like it's not here because this is the A, not the levels array. So we reach here. Where you teleport from level 2 to level 5 and from level 5 to level 8. Okay. Notice that going from 0 to 2 to 5 to 8 is not a feasible solution because it requires 3 teleportations, but the game starts with v is equal to 2. Okay, you need to implement your solution as a method min steps in the file main Java. Rating is 16 points, and O of n times v solution gets 16 points, and O of n to the power of 2 times v solution gets at least 6 points. Attention, you're not allowed to use additional imports other than the imports already included in the code template. Okay, it's cool. So this, again, as a written DP tasks, this needs to give us a hint about our DP table. Okay. So first, let's define our DP table together. And O of n times v solution means gives us a hint. And first of all, let's say, like, I know from this that our DP table will be 2-dimensional. And let's try to define a thing for dp of ij. So if we're trying to find out the minimum number of steps to reach level n minus 1, we can define our dpij like the following. Here we're allowed to use using v francs, right? Like if we initially having v francs. So dpi of j would be the minimum number of steps to reach level I with j francs in the bank, in hand. So now that you have the definition, basically the only thing that you have to do is to write these as an expression where we calculate our DP entry. So what happened when we were going from the step I to step I plus 1, we can basically do it for free. So DP I plus 1 would be equal to, using J francs, would be equal to the minimum of DP I plus 1 J. So minimum of DP I plus 1 and J till we, like, the minimum of DP I plus 1 J and DP I J plus 1. So this is for, so this is actually for the things that we calculated till now. If they are minimum, then we pick that and do nothing. We don't change the minimum. For example, if we arrived with a teleportation before to this level, then we basically pick that as the minimum. But how we can arrive at elsewhere, we can basically go from level I to level I plus 1 with 0 francs, so our J doesn't change. But we take one more step, that's why our step number increases. Okay? The other thing that we could do is to go from I to A of I. So what is our DP entry for A of I? Here you need to say J minus 1, because we're gonna actually use a franc for this. This would be equal to the minimum of DP A of I J minus 1 J plus 1. So why? Again, we could basically have something smaller here from before, from the calculations of before, and if so, we basically pick that. Or we can, if we're at level I with J francs, we can take plus one step and we can, buy our teleportation with 1 francs and basically teleport to level A of I, but now we have J minus 1 francs in hand. So that's basically to express this step. So at the end, we have our solution. The only thing left here is to actually code our solution in CodeExpert. So our code template starts with a bunch of library imports, and the main function, you don't have to care about the main function anymore. It's basically just for testing your solutions. But here what you have to care for will be the min steps function. So again, what are the dimensions of our DP table? So we have n-1 levels. We have n levels starting from 0 going till n-1. So this is our DP initialization. We have n levels, right? So because you start from level 0 and you reach level n-1, so there are n levels. We have V francs, but your franc can be 0, can be V. So it's basically, we need an array of v's minus 0 plus 1 to express this. So our dp table should look like the following. Oops. Here, I just like, after I define the dp table here, we need like I is for the levels, j is for the francs. What can the levels be? Levels can be 0, levels can go up to n minus 1. So, how can you express this in a table? You need n minus 1 minus 0 plus 1 n. And number of n entries. So you need the first dimension needs to be n. Or you can have v francs. So you can have 0 francs, but you can also have v francs. So to express all this, you need a dimension of v plus 1, right? Because v minus 0 plus 1. This is the easy formula that we use to do this. Right. So then we also need to initialize our dp table. So for every question, do this, please, such that you have a control on everything that you're doing. So this is basically the same for every DP question. So the left-hand side is the same. These two for loops will be the same for the initialization part. The thing that you have to decide is what are the dimensions and what is the initial entry for each, like what is the initial number for each entry. So here we are calculating with a minimum. So we can either say that what we have is integer max here, or in this case, we know that, where was it? We know that, note that it is always possible to reach level n-1 in n-1 steps. So I'm going to initialize the DP table with n-1 steps, because that's the maximum number you have at all cases, right? So that's why I'm not using integer max here. So like worst case scenario, you can just hop through every level and reach level n-1 in n-1 steps. So that's the maximum solution that we have. That's why I initialize the DP table like this. Okay. Moving on, we also need to initialize the first entry. So what is our, like, where do we start our entry? We start at level 0 with v francs, right? So dp of level 0, v francs. So what is this equal to? Think about it for a second. Like, what is the minimum number of steps to reach level 0 with v francs? We basically do nothing, right? We are already there at the start, because our start is at level 0 with v francs. So it takes 0 steps to do that, and that will be our initial starting point of our calculation. So now we have our initialization. Next thing that we have to do is obviously the calculation of the DP table. Calculation of every single DPIJ entries. So let me just say it like this. So the most important thing that you have to decide here is to actually know where your for loops start and end. So we need to do this with increasing I and decreasing V, right? Because we start at level 0, we reach level n-1, and we start at like v francs and potentially reach 0 francs or not at all. So we know that it's increasing I starting from 0, going to n-2, because we have, this will be more clear. The Y will be more clear. And we start with v francs the francs can be potentially 0 and j minus minus. So we do this by increasing I and decreasing j. So now why I is equal to n minus 2? Because we're gonna calculate the DP entries like this, I plus 1, right? So if it's going to be I plus 1, or A of I, which will be like bigger than I at all times, because we have this condition, you cannot teleport backward, and basically teleporting to the same level means nothing. So this is always larger than I. And that's why to for you to not have area out of bounds exception, I can be at most n minus 2, because we're gonna be calculating with I plus 1. N minus 2 plus 1 will be n minus 1, right? So that's how we initialize our DP table. So that's why I goes till n minus 2. So now we have two cases. First case, as before, First case will be e to I plus 1. Then the next case will be I to A of I, right? So then we have to write something here to calculate that DP entry. So what do we write? We write exactly what we have here. So it's basically one-on-one copy pasting after you have the idea. DP I plus 1 j is equal to the minimum of DP I plus 1 j till we calculate it till here, and DP I j plus taking a step. Same thing for I to A of I, but here we have to check if we have at least 1 franc, right? Because you can't do a teleportation with 0 francs, so we have to check if j is bigger than or equal to 1 here, such that we can do a teleportation. If so, dp of A of I is j minus 1 is equal to minimum of dp of A of I j minus 1 and dp e I j plus taking a step. So that's it. That's it. And why is that so? Again, repeating. Here, we basically copy the same entry that we had from the calculations before, just to check if we have a minimum thing that here. If not, we don't want to lose the entry that we had from before. And we also check going from level 1 with a teleportation to level A of I. During that teleportation, you take 1 step, it counts as a step, but you also buy this with a franc, right? That's why now we have j minus 1 francs on hand, okay? And to buy this teleportation, you need to have at least 1 franc. That's why we check it here. So we're basically done with our calculation. The only thing left is what we're gonna return, right? So extracting the result, as we would say it in an actual written task. Alright, so extracting the result. So what's the maximum thing that we can return here? Because we are calculating with minimum. So what's the max thing? It's again n minus 1, because you could reach n minus 1, level n minus 1 with at max n minus 1 steps at all times. So then to extract the result, we need to actually loop through the francs, right? Why? Because it doesn't change a thing if you could reach with having left with 0 francs, with 1 francs, with 2 francs. It doesn't matter how many francs you have left. The thing that matters is the number of steps. So that's why you need to loop through the francs once and check where you have the minimum result. So I do this with looping through it once and with the mathmin function again. And the result is at level n-1, right? Because we're trying to reach that. That's how we do it. So we loop through the francs once and we find the minimum entry of dp n-1j. So how can we reach level n-1 with minimum number of steps? So then we return our result and we need to be done now. So let's check. One extra thing that I want to show here is how to use this. So with DP questions, you can actually uncomment these lines and these lines to check your solutions. So public/0-example.in. What is this? This is the file that you're choosing to use for the tests. So you can also change this, but let's test with these first. You can basically see what was accepted and what was my output. You can also change the name of these files. So let's test with the small now. One, you can see this here. Okay. And let's test like this. Okay, now you can see we have a lot of correct results. And you can see what was tested here. Or you can use the example in and example out. Example in probably has the example we had here. Yes, it does. So that's a good way to check if you have a correct solution or not, and to basically see if it's wrong. You can basically see what you're outputting. For example, imagine if you had you can go to 1 here. Let's test. We have a bunch of wrong solutions. We're doing some things right, but we have stuff wrong. So let me show you with example again. Okay, here it doesn't change a thing, but let's say we made a really big mistake. Okay, now you can see the accepted is 4, but our output is 6. How can this happen if you only make one teleportation? So from this you can maybe derive that our loop is not right here. Okay, and then maybe you can fix things. So this is actually useful in some cases where you don't know what you're doing wrong. But don't forget to comment them again so you don't mess with your runtime. Okay, and now let's test. Yay! So seeing the green bar, right, in an exam. So it doesn't go up from here at ETH, I will say. I hope everyone experiences this, and I hope everyone sees the green bar and leaves the exam early. I really do hope it. You got this, guys. I love you all, and hopefully see you next semester. Bye.